and as a part of an educational and training session to uh, get people up to speed on what the possibilities are with these type of equipment. And many of you can be users of this equipment in the future in some form or the other. And there's establishes a baseline in your knowledge base to be able to reform and select and help design this type of technology into your facilities and plants that you may be working at, or on projects that you may be tasked to support. So with no further ado, I'll let our team of presenters. Go ahead, Brad.
Let me say one more thing here.
Okay,
if you look on the shared screen, go to your chat and look for this ExxonMobil and PLCNext for new open process automation YouTube. That's 3 years old. That's where PLCNext was first introduced by Don Bartusiak and Dave DeBerry of ExxonMobil, and the president of Phoenix Contact, Jack Nellig, and Ira Sharp, the product manager. And ARC Advisory Board first director, Harry Forbes, in this video, he, as he introduced, he said it was PLCNext is the future of industrial automation because it is an open source and open programming device. So look on your chats, and you can look at this video and look at the PowerPoint, and this PowerPoint also will be uploaded to the page. I will put that in the chat as well. So I'll shut up. Back to you, Ed.
Okay, well, go ahead, team, and we'll welcome right now we're at 8 people at the event here, and we've got more coming soon, as we're told. So I would just do a general presentation. Why don't you give us some, establish what we've done in the past, start out with what we've done in the last 3 sessions and what you're going to do in this session as the start off for this, if you would, please.
I can take that. Thank you, Ed. My name is Mark Dean. I'm a project sales engineer for Phoenix Contact. I work a lot in the process industry, so sorry. The PLCNext and the software development tool for it, PLCNext Engineer, is very new and different in the automation world. So what Brad was saying is actually really accurate. Being an open source based on a Linux processor, we're able to do a lot with this thing. It can do more than any PLC ever has in the past. So in my role at Phoenix Contact, what I do is I take it and I show it to our engineering firm partners, and I show it to large end users like cities and counties and rail systems and transit systems. And it's being very well received, not only here in California, Oregon, and Washington, but across the country. And here in Northern Washington, where you guys are at, we have an excellent team of guys there and girls who work with Phoenix Contact and provide you all the support and capability that you need. So I work with Evan Farris a lot, and I also work with Michael, and I'm going to hand this over to them now. But please remember that Mark Dean is also part of the team, even though I'm remoting in. Thank you.
Thanks, Mark. Thank you, Mark. First off, thank you guys for joining us this afternoon. I know it's late on a Friday, but really do appreciate you guys being here. My name is Michael Peterson. I'm the industrial sales engineer for Central Washington to the other side of Montana. So similar to Mark, I am responsible for our local system integrators and our original equipment manufacturers. So with that, I go in and I help specify our Phoenix product, and specifically PLCNext. A little background on Phoenix. We're a 100-year-old company. We're a family-owned, privately held company, and we started with the terminal block. So we are the inventor of the terminal block, which is basically an industrial wire mat. 100 years later, we have migrated to a automation company, and we are now going to be presenting to you guys a state-of-the-art open source PLC. Within the Pacific Northwest, similar to what Mark was just talking about, we do have a great team of product vertical specialists Evan Farris is one of these specialists, and I'm going to hand it over to him and let him do a deep dive on the state-of-the-art PLC. Thank you.
Sorry, there was that like weird thing on the screen. I had to get rid of it.
We didn't disconnect anybody, did we?
Here we go. All right. Beautiful. Thank you, Michael. All right. Hello, everyone. My name is Evan Farris. I am also with Phoenix Contact. I am the automation sales engineer. So that is a bunch of fancy words that mean I focus on PLCs and IO, and I also focus on networking products and pretty much anything that's based on Ethernet. That's my focus with Phoenix Contact. So that includes the PLCNext here that we're going to talk about today. The PLCNext, as Michael said, is an open source product, and it was released about 5 years ago into the market, and it's been really well received. And every day there's always something new being added to it, which is really cool. So Phoenix has been making PLCs and IO for a very long time, along with a lot of other manufacturers. And we really, took in the feedback from our customers and learned about the market during that time and really built up a strong industrial portfolio. And we realized there was a big need for something like the PLCNext, where people could actually do something that they want with their PLC and not spend thousands of dollars on software fees and licenses and all these things that you can get bogged down with in the industrial space. So we developed the PLCNext 5 years ago, and like I said, every day there's something new added. They're constantly developing the program, and then with the PLCNext, there's a lot of different add-ons that you can get. And so it's pretty expansive and it's limitless. And I think that in, 5 years from now, it'll be twice or even 3 times the capability that it is today. So it's a product that's going to stay the same, and you can just update the firmware and then it'll have all these really cool new features. And then if you need to add some, other physical things, it has a bus that everything is connected on inside of the DIN rail, which is what everything is snapped down to. And that allows you to expand the device left or right and add more features to it if you wanted to in the future.
So Evan, you keep saying the word open source. What is that, and why is that different than the traditional PLC in the market?
Perfect. So if you go to this, yes, we'll skip past this. We'll talk about this. So evolution of PLC. So does anybody know what a traditional PLC is utilizing to do their code or their processes?
Say ladder logic?
There you go. Brad got it. All right. So ladder logic. So that was how everything really began in the PLC world. But ladder logic is actually based on relay logic. And so it was a way of thinking about, electronics in a relay sort of fashion. And that has carried on for a significant amount of time. And in fact, it is probably the most common thing we still see out in the market. And the thing is you're wondering why things haven't adapted over time and they haven't just gone to coding like a computer would be or anything else. And in an industrial space, you want everything to be really simple to interpret. You want everything to be able to withstand any kind of changes. So, a lot of times with software, you can get little bugs, and that little bug may, affect the entire program from working properly. Whereas in ladder logic, you can look at it and you can see obvious, mistakes or something like that that may be going wrong. So that brings us to today and Michael's question. And so they've developed all these industrial protocols. So you may hear Ethernet IP, and you may hear Profinet, and you may hear Modbus TCP, and all these different protocol languages that an industrial controller would speak. This was great. It allowed a lot of improvements into the communication of lots of different devices into a network, a lot of different PLCs and controllers. But it kind of created a clash where you had to stay within a manufacturer. So if you wanted Profinet back in the day, you had to use a Siemens controller or something similar. If you wanted Ethernet IP, you had to use Rockwell or Allen Bradley controllers and products. And so this carried on for quite a while, probably, 30 years or more, where this was kind of a standard. And then companies like Phoenix Contact tried to come in, and we started making products that would be compatible, but it wasn't totally the same exact thing. And then other companies started making products that were Profinet or Ethernet IP, but it was still kind of locked down. And so you can kind of think about it as like an Apple versus Android. So an Apple product, you get an iPhone, and then you have to buy their proprietary charger and cable and connector, and then you have to use their, all their different stuff that is into an iPhone, and you're kind of locked down, and there's not really much you can do beyond that. And then we have Android, which is pretty open, and you can really do whatever you want with that. It's kind of yours to make. Of course, there's going to be operating systems and things like that, but really at the core, you can kind of do whatever you want, sort of like a Windows computer, and going even further, like into a Linux computer, if you were comparing it to a MacBook or something like that. So that's where Phoenix went. We decided, well, why is everybody making these iPhones when we can make an Android? And so Phoenix, we came out with a product called PLCNext, and this really is a completely open source Linux-based type of controller. So with that Linux base, we can do really whatever we want with this DLC. So if you want to go forward. There's a lot of different things. So here we're showing with the PLC, there's, you get the open source control platform. So you're going to get all the standard control that all the other PLCs on the market have. So that's going to be your ladder logic. There's a thing called structured text. It's a text based coding, but it's utilized in the industrial space. And then we also have function blocks, which are pretty much structured text packaged into a nice diagram that you can easily interpret and perform actions with. So that's already built into the controller, ready to go. So it already does, the standard types of controls that people are used to. But we take it a step further, and you can add your own code onto it. So if you know how to code in Python, or you know how to code in C, you can take that code and you can utilize that on your PLC. And you can utilize it by itself, just running on its own, or you can utilize it in conjunction with all the traditional industrial protocols that are going on. So there's a lot that you can do with it. So we have our own engineering software, and this software is being developed all the time and improved. And this is a completely free software. So another thing about being open is you don't want to be charging all these software fees and licenses. So I buy a PLC, and then I have to pay, some dollar figure that's way larger than I want to spend. And then I have my PLC, and then about a year later, they're like, hey, you got to spend some more money to utilize it any further. And so that's a big roadblock in the industrial market, and something that an open source would prevent.
So what kind of security are you guys doing?
Security and how?
All of the people that are trying to break in and take over your plant.
Absolutely. And we have a slide on that in a little bit, so we'll get to that. The PLCNext is actually fully safety rated. And so this is essentially, it's actually the only PLC on the market that has an industrial cybersecurity rating. So pretty cool. Yeah, so we talked a little bit about the engineering software. This is the place where all the magic happens. So you'll type your code in here, your traditional code. You'll import any kind of code that you would have written outside of the program, C, Python. This is where you would install applications that you get from our Phoenix App Store, and I'll dive into that in a minute. And then this is also where you lay out your entire program structure. So the order of operations, what happens first, how is it operating, what are the priorities on different programs. And then this is also where you would develop your HMI, or human machine interface. And that's essentially the screen that you would touch or interface with. So an old control panel would have a bunch of lights and buttons on it, and you would press those, or there would be a podium off to the side and you would do that. But an HMI essentially allows you to visualize all of that in a prettier package, and allow you to have more capability and flexibility with what's going on in your system. So we talked about this, the IEC 61131-3 is the programming. What would you even call that? The category?
That's basically where your structured text, function block, and ladder logic sit. That's kind of the industry standard. So
Yeah.
To Evan's point, with this PLC, we have the Linux base, and that's where we have our higher language functions, your C, your Python, your so on. On top of that, we've embedded the IEC 61131-3, where you can still interact with those traditional industrial program or coding options.
Yeah, so it's essentially the industrial standard for which code is, and that's, like you said, the structured text, ladder logic, function block, that sort of thing.
Let me mention that IEC is the international standards body. That standards are not they're not mandates. They are really suggestions as to how we can do everything across the globe similarly. And so IEC is ISA has 112 standards that it's developed in 75 years, and a lot of those standards have been that ISA developed were just strictly adopted verbatim by IEC. And so we create the standards, and IEC also creates their own standards, but IEC just rubber stamps and accepts ISA standards. For example, the cybersecurity standard is IEC 62443 that was created by ISA S99. So.
And we are the current holder of that cybersecurity certification too. This is the only PLC, like Evan said. Open does not mean unsafe.
Open means flexible.
Yes.
So yeah, we talked about that, the programming. Another programming thing that you can do is you can embed the MATLAB and Simulink programs in it. So I went to school and I got a chemical engineering degree at my university, and this was the program we used from freshman through senior year. And I did more than I would like to do on it, but I think it's an incredible program and there's a lot you can do. And I think it's pretty cool that you can combine that into the PLC at the same time.
Yes.
Cool. So we talked a lot about, all the things that you can put on there in the code. So here is just a nice breakdown. You can utilize, MATLAB and C and PLCNext engineer programs and that IEC standard all at the same time. So I talked about the PLCNext store. So this is really just like an app store on your Android phone, your iPhone. So you go to our app store and there are vetted apps that Phoenix Contact will go through and vet that other people create. Phoenix Contact has also created a significant amount of programs, including one that I know Mark holds very dear to his heart. It is our PLCNext pump control program. So it is a full-blown pump controller program that we have developed, and where you can pretty much do, very basic pump control. At this time, it is expanding pretty quickly, and it's pretty cool to see, how we can take a product that has been you buy a standard controller for pump control in the market. So you go buy something like a flight controller. That's just been the industry standard since we can remember. And so having a product that you can take that's off the shelf and you can do whatever else you want with it, but you could also do that is pretty cool. So all these different programs and different things that you can utilize to take advantage of, including, I want to utilize this industrial protocol like Profinet, or I want to use, Ethernet IP. You can get all that from the store and load it onto your device. So it's more of just this open platform thing that we're talking about, where you can take an existing device and you can add more to it if you want. And then finally, the community is really just a forum and a page where people can ask questions, people post guides and information. So if you have questions about PLCNext, this is probably a really great place to start in getting basic information and kind of getting, an idea together of what the possibilities are, and seeing, real world applications that people are putting up there. So we talked a lot about the industrial protocols that you can add, and there's a lot of other protocols that you can add, including data acquisition protocols. So one of them being OPC-UA. It's another protocol essentially for getting information and sending that information up to the cloud in a secure fashion. So up here, you can see all the different protocols and different things that the Phoenix Contact PLCNext can do. So on the left side, we've got all of our different field bus protocols, all of the main ones, including a lot of ones that you may or may not have ever heard of, as well as a lot of these different general communication interfaces and APIs and other things that you can utilize the PLCNext with. So this list has grown since I started with Phoenix 3 years ago, and I imagine it's just gonna keep getting longer until we gotta have a second slide for it, so.
Which again is significant. As Evan mentioned earlier, traditional PLCs have one protocol that they use, or one or two. Again, with that openness and being able to play well with others, we've been able to adapt and utilize the industrial protocols of the market.
And then we talked about a cloud. So this device is already set up, ready to go with the OPC UA that I talked about. And this is for getting information to the cloud. There's a lot of other ways you can get it to the cloud, and those are also achievable via PLCNext. OPC UA is just a very common one that people are aware of in the market. But you can send up any information to any cloud, whether it be a remote or if you wanted to have a local cloud on a computer somewhere in your network, you can totally do that too. So it's really kind of open to whatever you want to do and where you want to send information, or if you want to even send information anywhere else. So
On that, if anybody looking at doing the project that Professor Osmond was talking about, he was also talking of being able to control that little manufacturing floor simulator from the web, and this would be, we have the access to PLCNext, so that would be one way you could do it.
I know, actually, I have a question about that one. We gonna purchase, we already purchased two set, and then we're gonna purchase others, but we didn't actually purchase Siemens PLC, because as you said, that like license fees and all that. So we'd like to use our like PLCNext, and then maybe that's, I mean, it sounds like that's the kind of regional control. I'd like to know where you're located to your local,
So, the way we go to market here in the States is we go through distribution. So local distribution here in the Tri-Cities would be Stoneway Electric. And then we do have, online resellers as well. So RS Americas, which used to be, Allied Electronics, Mauser.com, as well as DigiKey.com. And we can talk after too, and we can talk about what IO and such you're looking for. And we can give you some recommendations on what would be good for a class setting.
yeah, we both live in the Northwest. So I live over in the Seattle area, and then he's over in Coeur d'Alene, in northern Idaho. So we're both local and we come here quite often. So we'll definitely be around to be a resource, or if you want to reach out, we can do a Teams meeting or a call, whatever works. So cool. So kind of just a little bit blurb. So AWS has qualified the Phoenix Contact PLCNext as a cloud device. So that's pretty cool recognition by them. So onto the security that you were talking about. So IEC 62443, and this is the industrial standard for control systems. And Phoenix, like they said, is the only one that qualifies with the PLCNext. So. And then this is a little bit about OPC UA that we talked about. So it's really about taking all the information, all the data that you're acquiring from your sensors and other information, and taking that and sending it to a cloud or an ERP system, or however you want to utilize that data for your advantage. So. And then this kind of gives an overview of, how it's all put together. So we have the hardware platform, and then we have on top of that is the PLCNext operating system, which is Linux. And then built onto that are all these different features and add-ons that you have. So examples of where we see the PLCNext, there's a lot going on here, but essentially we have three layers. We have the cloud, we have the factory, and then we have the field. So the field is where all your machines and sensors and everything is going to live. And then the factory level would be like a server room local, and then the cloud would be something external. Or it could be another local area where you have device management going on at a higher level, like your IT group. The next one where, example would be to little noise going on. So the next level would be taking the PLC, and instead of doing the direct control on the field level, it would be doing an edge device as well as the control on the field level. So essentially, you can utilize the PLC to do the control alone, or you can to do control and data acquisition, or in the next example, you can use it exclusively with data collection purposes as an edge device with a third-party PLC, such as an Allen Bradley controller or a Siemens controller or Schneider or whoever else might be developing a PLC that you want to work with.
Our mission and focus here at Terra. Every member of our team takes pride in delivering exceptional service. We look forward to
Brad?
helping you create your success story. Thank you for calling. We'll be with you shortly.
I'm hearing a telephone call that's coming into the meeting.
Yeah, we've muted everyone. We're good.
All right. Beautiful. Okay, back on track. So we talked all the things that the PLC can do on a control level, but when you get to the physical environment, something that's really important in industrial space for a lot of people is this topic called safety and making sure that your machines aren't getting destroyed or your humans that are operating them are not getting destroyed. And so this PLC can also work as a safety controller in conjunction as a standard controller. And so I talked about adding modules and things. And so the PLC, you can add a Profinet or a ProfiSafe, which is a Profinet protocol for safety, onto the PLCNext bus. So physically attach it to it. And then this allows you to run all of your safety control on that in a different processor to make sure that all of your safety functions are operating and no one gets hurt.
Is that safety system? Mark, I guess, is it certified by TUV?
Yes, sir.
61508.
61508? Okay.
Yep.
That's S84, I guess. Yeah. Okay.
Perfect. And then to sum it all up, these are just some examples of the things that you can add. So right here is the PLC. This is an extension module that you can put on the left side. And then these are all just different flavors of inputs and outputs that you can have on the PLC. And so color coded to mean something. So gray is standard IO. Yellow is safety. So that's how you know it's a safe IO. Blue is safe for process. So this means intrinsically safe. So not creating enough energy to create a spark, which could ignite some fumes and then make an explosion or something fun like that. And then on the left side is just another example of a different type of IO, but it's gray, so you can identify it as standard IO. But this PLC has a lot of different things that you can add, and you can go left or right or anywhere in between.
Which again is a little different than the traditional PLC in the market. The traditional PLC in the market, you had a back chassis. You would put in your processor or your PLC head station. And then from there on the right side, you would start throwing in your IO cards, your analog, your digital, whatever that may be. So with this, being able to add to the left side and to the right is pretty significant. Now still, we'll be doing IO on the right. The left will be adding a safety controller, an additional Ethernet card or NIC cards. We have machine learning cards, and that'll continue to evolve with whatever the industry is going to need.
So the difference between on that, the gray is just regular IO and the
Yep.
yellow is safety.
Yep. And then the blue is process safety. So. Perfect. And then these are some examples of the left-hand modules. So machine learning, safety, it's yellow, so you know it's safe. You can become a Profibus master and all these other different things, including adding another Ethernet port, which could be very handy if you want to have more than one IP address on the device. So. And then really kind of to sum everything up, it's a totally scalable device. So you can keep it really simple and do very simple control, like an upgraded Raspberry Pi or Arduino, or you can take it all the way to a full-blown safety controller that's also sending data up to a cloud and 100 other things at the same time. So you can really do a lot with it. And that's why we're here to talk to you today about this, is because you have one that you can utilize. And so we would love to help you out with that and, help you with your learning journey. I mean, they're a little bit intimidating. I think, you know, it's like a fancy computer and it seems a little bit different, but really at its core, once you start playing with it, you'll find that it's actually really cool. And there's definitely something that's special about a PLC versus something like a Raspberry Pi or an Arduino. It feels like an upgraded version. And so I really urge you to look into it, you know, just at least try it out and see what you can learn from it. I think some of us, I know that, you know, I got a chemical engineering degree. I had no idea that I would end up in the industrial automation space, but things just happen and you'll end up in a spot where you're like, this is pretty cool. And so I think that, you know, you may find that in something like this controller, and it'll help you on a learning journey where you'll be somewhere totally unexpected in 10 years from now. So
I had a PLC instructor tell me years ago that my only limitation on a PLC is my own imagination. You can do anything you want. It's just how you code it.
And Michael and I, we are technically salespeople, so we are going around all over and meeting with different customers, trying to promote these products. But we see a lot of really cool applications, and the amount of things that we can see a PLC do is just mind blowing. Sometimes you're like, man, I feel like the dumbest person that ever lived, because these people are, I don't know how they make this, you know, 100-foot by 100-foot machine doing all these things and everything's moving and, you know, all these lights flashing. It's really impressive. And so, you know, got to start somewhere. And I know that some of you are definitely going to be doing that. So just a matter of time. So.
Last thing we kind of wanted to touch on, something that Phoenix we're really proud of, is our quality of product. And with that, we offer a lifetime warranty on all of our products if you put one of our surge protectors with our power supply. So we'll lifetime warranty anything downstream of our power supply. So that's our last little piece. We always like to talk about our LLW.
No other industrial manufacturer has any kind of warranty that goes over 5 years. So that's pretty impressive.
So that's all we had for PowerPoints. We didn't want to PowerPoint shit to death. You guys like to see the software, see an application up and running, and we can play around a little bit. And then obviously, if you guys have any questions, please, we're open.
Any questions at this point?
Oh, I'm sorry.
Cool projects.
I all sorts of stuff. My job's very. Have you seen the show How's It Made on Discovery Channel? Okay, so basically the show, the host goes into different industries every day and sees how different things are made, from a pencil to a vehicle, right? That's kind of the role we're in. We go into different industries every day. So in my territory, I've seen huge logs, trees, in a matter of minutes get cut down into dimensional lumber, all automated. Some of the coolest wood product machines I've seen is how plywood's made.
Yeah.
Basically, they take a very large tree and they poke each side of it and they start spinning that tree really quick. And they have a long knife blade on that backside. And as that tree spins, that knife blade slowly pins into it, kind of like an apple peeler. And coming out are just sheets, paper sheets of wood. And as it's flying off of that, what was a tree trunk, it goes onto a conveyor. And again, you got to imagine this is going hundreds of miles an hour. It's flying. And there's a camera above grading each little sheet, and it knows immediately what that grade is. And it has a conveyor that kind of goes up and down. Good quality goes up, bad quality goes down, and sheets are just flying. Paper sheets of wood are flying until it goes to the next stage. The next stage, they start laying it on top of each other, adding adhesive and glue and heat, and then squeezing it down. Now you just have these big, long sheets of wood. It goes to the next phase, it cuts it down, then it goes to your hardware store of a 4x8 sheet of plywood. To something a little bit smaller scale, there's a company in Yakima that makes bread clips. So you go buy a bag of bread and it has that little plastic clip that holds that bag shut. We have a company here locally that's fully automated. It comes from a roll of plastic, and out the other side are these little bread clips. So again, everything that we touch every day, there's some sort of automation that went into creating it, right? From water bottles to glass. I've been in a glass facility and watching them take sand and heating up the sand in a huge kiln and making basically liquid molten glass and watching it go down into its form. And again, it's quick. It's incredible.
It's hot.
And it's very hot, yes. Yeah, when they open up that kiln, they put a huge screen in front of you to block that heat, but you're still able to see through it. And there's a couple of really cool YouTube videos of SOI glass that's out of Longview, Oregon. Or Longview, Washington, I apologize. Yeah, some really neat stuff out there.
Yeah, and then on my end, I live over in Seattle, so I've seen a lot of stuff that goes into Boeing operations for their manufacturing process of airplanes. Pretty crazy to see what they're doing and all the different machines that they have, you know, picking and placing and making carbon fiber sheets for the wings and all sorts of different things like that. So yeah.
And with some of the data acquisition and the cloud storage and such, what we're seeing a lot of right now is gathering that analytic data. Upper management wants to know why a machine went down, at what time, so on. And we can now gather data with different sensors and instruments out in the field in parallel with our PLC, where we can get it down to the exact second that went down and who was on that line at that time. And did Evan go over and press the wrong button on the control panel or touch something on the HMI that caused it? And then automatically calculate the losses and so on. So, and then again, turning around and making that more of a predictive maintenance schedule rather than a preventative maintenance. Yeah, there's a lot of capabilities. We're seeing a lot of really cool things out there, from robotics to all sorts of really, really neat stuff.
And I would just add that what I'm seeing a lot of is not only the automation that makes these things really cool, but massive networking, the need for massive networking, statewide networking. And this is where cloud connectivity comes in and cyber security comes in, data acquisition comes in. That's what's really growing in my world. And this processor does a really good job with it.
Perfect. Well,
I wanted to throw out a few things during this discussion. To go back to lateral logic, in cases where people are not on the leading edge of technology, but sometimes you have a workforce does a lot with switchgear and MCCs and that sort of stuff, and they're embedded into the lateral logic world. And then you expand on it, and then you get them into the PLC. It's an easier transition across when you're trying to get people to operate a facility or whatever. I'm thinking that's one thing that I've run into. Another is, on rare occasions, sometimes it's to the point that they want to run the system manually, because the workforce you have, until they get enough workers that are trained like students in this meeting are, that they can operate. You need to the people actually going out there at the facility or whatever. And I'm talking, when I say facility, I'm not talking about a small footprint. I'm talking 20, 30, 40 kilometers of distance, and then maybe a leapfrog to another city 70 kilometers away, and tying those things together to have a central location where there's certain parameters and there's certain things that are necessary to run an operation, like on even a simple irrigation system, to put those parameters down to that specific PLC so that it will run or not run when it's in an automated mode, of course, and taking all that data back, which is very important. You need to know when there's a trouble, something's broken down. That's equally important as the maintenance of a facility, to keep it up running. This is critical. You guys didn't, when you get in these production, downtime's a killer. And the operation manager, all the techs and everybody, they're running until they get the problem solved. And the simplicity of the programming is critical, and being able to get in there and go through it and find out whether, it's usually not the PLC programming or system, it's some discrete detector or sensor that's been damaged or has gone bad or needs replacing. It's simply that. But it affects the whole line. It affects the whole operation. You can up to $1 million an hour and so there's a lot of pressure on people to be able to address that. But you get back up to the PLC and you got the HDMI and all this, or the HMI. You got to be able to find where the problem is, and if your software is good enough, and if your basic fundamental engineering of the system is such where you can go and you can help somebody address and troubleshoot and find problems, that can be equally as critical as anything else we've talked about. Although the safety issues are all fantastic. One thing I didn't hear stated, that's my second question, is plug and play. Is there a plug? Lots of times when I put in systems, we had to have sometimes redundancy on the safety systems. I didn't hear mention of that. And then secondly, I didn't hear plug and play. Is your system smart enough where if the controller's over on the side here, I can unplug and put the new one in, and it will put all the parameters and everything in the logic and run the thing? Do you have that capability with your system? Please go ahead.
To answer the first question, for redundant systems, yes, we can do redundant systems. We have certain PLCs that can be in redundancy with each other. So if one of them fails, the other one would take over, and your process would not be affected by that. And then the second question was talking about the
So plug and
swap.
play. We are hot swappable, but you're gonna have to hot swap with the similar IO card. If you take out an analog and put in a digital, your coding is going to be looking for the wrong tag. But we are hot swappable.
Yeah.
Is any of that in your demo?
So for
Repeat that
example,
question, please. I could not.
for
We
example,
could not understand that question since you're away from the mic.
Is our
Barb,
demo
question?
hot swappable was the question.
Yeah.
Okay.
Is it featured here on the demo? That's the
So,
question.
so the hot swap feature would be, you would have to utilize an SD card on your PLC.
Yeah.
So the program doesn't just live in the ether, so it has to live on something. And if you're swapping out devices, that program doesn't just transfer over to the other one. So you would have an SD card that you would put into your PLC, and then the PLC would load the program onto the SD card. And then if the SD card, or if the PLC was to fail or you wanted to swap them out, you would just pull it off, pull out the SD card and then put it in the new PLC, and the program would now be on the other PLC. So.
Okay. Thank you.
Evan, what about a digital IO card though? Can we pull a digital IO card out and put it back in? Thank you. See, now that the PLC is unhappy, but once we replace it, it recognized the card and it said it was okay.
Well, okay.
All right.
Let me share the screen a little bit. I think I need to explain the whole purpose of the open systems. You may not understand the purpose of why being open source it was so important. ExxonMobil, Don Bartusiak, and he founded that program because ExxonMobil had a lot of aging control systems, and they were tired of, they were going to have to spend billions of dollars to replace them. And they did not want to they wanted open source because they did not want to have vendors tend to charge as much money as they can once they get you to buy them. I don't know if you students know that, but on the shared screen here, I put a link in the chat for this open process automation forum. And here are some of this may be too small for you to read. You may have to go look at the open process automation forum. They have these gold, platinum, members and all over the world. You can find control system vendors, and you know, and you can find the just the users as well. So I mean, scroll
Are
through
you
down the
sharing your
list.
screen? Are you supposed to be sharing your screen?
Excuse me? I guess
No,
I'm not
it's in
sharing
the
it.
chat. It's in the chat, Evan.
Okay.
It's in the chat, and maybe you could call it up and share the screen. That'd probably be better, in fact, if you go to the chat.
It was in the chat. There it is.
Loading up.
And look at the blue script writing of open group. Here's Shanki Mo coming in to our meeting. But if you look on the chat to see Open Process Automation Forum, opengroup.org. And so just want to say to you students, don't don't pass up this opportunity to work with the future control systems. You've got a huge opportunity. Do a senior project with it and be the,
Brad,
yes,
can we have them do their demo? Because my students are out of class here in 10 minutes.
wait, excuse me?
We're gonna hijack you a little bit and take do a little dive into the demo and the HMI and such
Yes.
as we're getting close to time. Thank you, Brad.
Maybe and maybe you can call up the automation or PLCNext engineer software and have them see
Yes, sir.
where you turn things on and off.
All right. I guess I'll share my screen so they can see. Maybe that would be a nice thing. All right, so right here I have the HMI screen going. So this is the PLCNext running on a web browser right now. So our PLCNext utilizes HTML5 for the HMI graphics. So what this means is you can pull it up into any web browser because they use HTML to display graphics and everything else on the websites. So
fully scalable, you could pull up this IP address on your phone right now and view it.
yep. So I'm viewing via my computer, and then of course we do have physical devices like an HMI would be on a control cabinet or out in the field. That would look like a nice fancy touchscreen that's washed down safe and very resilient. So this can really run anywhere, and it's pretty cool that you can simulate it or run it onto your web browser so you can really play around with it before you actually send it out in the field and scale that. So on here we do have my PLC right here running this software. I want to see. Minimize that, let's show it. Can you turn off your, I wonder if I can do that at the same time. Can you, Mark and Brad, can you turn off your cameras so we can share the PLC?
I'm sure it'll make a. I shouldn't have. I wonder if I'm spotlighted, but I did not spotlight. I don't.
You just got to turn off your camera.
Okay,
Just
just
gonna
did.
make it real small.
We get the gist of it.
Yeah. I'm gonna try to show them side by side, but I guess.
Well, okay.
All right.
In
so-
the browser, click the participants to turn that off. Or hopefully you're using Teams.
That's all right.
That's
We'll
not
walk
big
through
deal.
it.
All right, so what you'll see on the screen is going to be mimicking what is actually physically happening on there. So we have a bunch of different I/O on here, ranging from digital outputs, and then we've got analog and then some digital inputs as well. So Through this program, we've developed different things. So this one is a running light. And so you'll see the IO kind of jingle back and forth, and that's actually happening here on the device. So those IO are being triggered in a linear fashion. The next demo that we have on here is something like brewing coffee. So this bar graph is slowly filling up. So the IOs are slowly turning on after flashing, and is mimicking about how tall the coffee has filled up in this example. So this is our brewing coffee demo. And so there's really a lot of different things you can do. Not only are you controlling this, but you're making the screen match that. So for example, in a real world, you could be filling up a tank with some kind of fluid or something like that, and you could actually see how full your tank is with a visual indication. And oftentimes people need that visual indication to know that something is wrong. And so that's a big part of industrial systems, is making any person who could possibly be operating it know without a doubt that something has happened and they need to take some sort of action. So pretty cool. Here we have a binary clock, and so essentially based on the time date stamp, which is not accurate here, it would be reflecting that clock on the IO as well. And then I don't have a slider here, but essentially as an analog would come in, you could have a 0 to 10 volt signal come in, and that would adjust for you as well.
So on your guys' unit here, you have this potentiometer. You guys have this file loaded on here as well. So if you were to open up the HMI file on your guys' PLC, you could adjust your potentiometer and you would watch that slider gain or decrease. So.
And then these are all the digital inputs as well. So these little switches would trigger to each one of these inputs, and then you could correlate them to outputs or however you wanted to do it.
So real world, again, we could have a limit switch that a piece of wood, we'll go back to the lumber industry, a piece of wood hits a limit switch and it opens, and now it's triggered that. So now the PLC knows that that piece of wood has hit a limit point, move on to that next process or sequence, and so on. Your potentiometer again could be a float or a level of height. So there's a number of different things. Again, it's all in what you're trying to accomplish and what tools and instruments you have out there to utilize.
Yeah, it's oftentimes about figuring out what sensors and end devices you want to use, and then matching it up with what you need on the actual device to read those signals. So.
Since we're getting kind of close, Evan, you want to give them a quick rundown of what that PLCNext engineer software looks like?
Yep. So at the core of the PLC, we've got a couple different sections. We have on the right side what you see as components. These are all the pieces that make up your PLC programming. So this would be all the programs that you develop, or any imported applications, or anything to build your HMI with. So these are all the components and bits and pieces that you have that you can put into the actual running program in order to have your PLC operate. On the left side is kind of all the different avenues that we can go into the PLCNext core. So that could be going into the HMI section, or that could go into selecting how your programs are running, and what fashion are they going to be, in a cyclic fashion, or if something happens, is that going to become a priority status and run first? And this is also where you would find all of your tags. So this is where you link, inputs into, virtual tags, which would live on your HMI. So if you actually press the button, that would actually correlate to a physical input or output or something like that. And then kind of in the center is where you actually do all the modifications and settings adjustments for the PLC. So for example, if I go into the HMI web server, we have all of our different screens living on here, and this is where you'd actually develop and build your screens, and then you could link them to individual tags. So all these different image files would be linked to some sort of dynamic but. And then, each page has their own builder. So you would go through and you could build all these graphics onto it. And then if you wanted to come in and edit your code, got a few programs on here. So this is an example of a function block. We've got a function block going on here where it looks like, I'm not even sure what this one is doing, but there's a lot of different code that is written in this one to do things. So this is an example of what ladder logic would look like.
So that there is a latching circuit.
That was a latching circuit.
Yeah.
And then here is an example of what structured text would look like. So it's mostly if else statements. So there's a lot going on here, but what you can see is that you can pretty much turn really any of these words and, you know, text to actual physical outputs and things happening and data information, you know, going to some place or so. It's a lot going on, but we definitely urge you to start playing around with it. And it's, you know, once you start actually getting familiar with the software, it's pretty easy to navigate, and you can really expand limitlessly from there.
So I know we threw a lot at you. Thinking, excited?
Any questions?
Any questions?
Does anyone want to use it one day?
Let me add my 2 cents from when I was in college to take ME 46. Most people took ME 416, which was building a race car and designing gears. Well, there were 10 of us that could care less about gears. So we instead took 417 and we modeled the coal-fired power plant with Fortran. And so I would suggest that you, if you don't want to do a senior project with, I'm not sure the equivalent electrical engineering, but take the road less traveled and talk to your advisor and get them. They will probably allow you to do a senior project and get credit for something if you delve into this. You can tell your professor you're using the latest technology, the future of industrial automation.
Well, we really do appreciate your guys' time today, staying late on a Friday. There's really neat stuff out there, really neat stuff to be done. There's a lot of really cool things going on here in the Tri-Cities as well, utilizing a lot of this industrial automation. So when you guys get out there, know Phoenix Contact's here to support you guys. We have cutting edge, innovative technology, and we look forward to working with you guys soon. Thank you. Thank you, Brad.
Thanks, Fred.
Yeah.
Thanks, Mark.
Thank you, Mark.
Thank you guys very much. Great show.
Thanks a lot.
Thank you, Michael, Evan, and Mark. Thank you.
Yeah.
Thanks for having us, Ed. And Andrew, good to see you, by the way.
Yes, where are you? Wave. Okay.
I'm over here.
Ed, was that Ed talking or Mark?
It's industrial.
Ed.
So it doesn't break.
Here we go, Ed.
We
Ed,
tested that.
good to
Yeah,
see you,
He's
Ed.
up there.
we have
I
surge
see.
in front of it, so it's covered.
And Mark, you are my, you are down the hill from me as always.
And last year when I was here.
Yes, sir.
Yeah, and I
I
do
have another
drive by your
garage sale
house.
someday you can come to.